In the midst of the huge show of the universe, we waver on the cusp of earth-breaking exposures. That obligation to adjust our viewpoint on the universe, the presence of the James Webb Space Telescope fosters the extent of our brilliant assessment, assessing further into the favored bits of knowledge of reality than any time anticipated, leaving on this new pursuit. Through James's knowing, we offer an individual check of the unusual early universe. Out in this manner, depict standard incalculable standards as we experience into this illuminating area. The mosaic of our appreciation spreads out, revealing unconventional plans and disguised intricacies. They oblige us as we plunge significant into how James Webb just perceived enormous plans that shouldn't exist. Could you ever imagine investigating a time machine, revealing stories from age to work out insistently? The James Webb Space Telescope has done basically that. Its for the most part significant field picture, produced from a mosaic of 690-man outlines, depicts a fix of SK in space, the gigantic scoop's handle, generally on multiple occasions more noteworthy than its ancestor. It's like holding an enormous interstellar jigsaw puzzle where each piece is a specific universe from the early universe. These photographs present a complex, tricky dance of systems, some of which existed essentially an enormous number of critical timespans after the tremendous impact. Their delicate shimmers are a quiet confirmation to their distance and age, revealed by the unrivaled INF-end responsiveness of the near-infrared camera. This observable, an enormous leap in bombastic assessment, yielding astounding reconsiderations into the universe's nth stories. Up to now, maybe the best divulgence before 100 extended lengths of it is that our home to zero in on the universe changes, what's more, makes with time, not simply in minor, unimportant ways like stars moving about, gas hazes pressing, and enormous stars bombing hopelessly in tragic influences. No, our entire universe has changed its fundamental appearance at least multiple times in the distant past, absolutely changing its inside state at an overall inescapable scale. Take, for example, the reality that at one time in the overcast, iller past, there were no stars. We know this essential reality in light of the way that of the presence of the unfathomable microwave foundation, a shower of delicate but creative radiation that soaks the whole universe. Assuming that you experience an inconsistent photon, a smidgen of light, there's a good opportunity it's from the colossal microwave foundation. That light takes up more than 99.99% of all the radiation in the universe. It's an extra from when the universe was only 270,000 years old and progressed from a hot, irritating plasma into a fair soup with no positive or negative charge. Change conveyed white-hot radiation that all through the scope of 13.8 billion years, chilled and stretched out off into the microwaves, giving us the establishment light that we can recognize today. At the season of the presence of the cosmic microwave foundation, the universe was around 1/1,000,000th its ongoing volume and enormous number of degrees. Truth be told, it was too fundamentally uniform to bubble with density differences no more noticeable than one section in 100,000. So, not conclusively a state where stars could joyfully exist. In the period following the transport of the cosmic microwave foundation, delicately known as WMX in space science circles, the universe was in an odd state. There was a consistent shower of white-hot radiation, but that rotted part was rapidly cooling as the universe went on with its relentless development. There was faint expected outcome hanging out, disdaining its own business. And there was the, at this point, unbiased gas, essentially hydrogen and helium, finally set freed from its fights with radiation and free to do what it satisfied. Fortunately, it didn't need to lock in the early universe. Little quantum dangers reached out to turn out to be only contrasts in thickness. And why that happened is a story for one more day. These tiny thickness contrasts didn't impact the more noteworthy cosmological gain, but they impacted the presences of that fair-minded hydrogen. Any fix that was to some degree denser than ordinary, even by an insignificant little piece, had a to some degree more grounded gravitational draw on neighbors. Upgraded pull asked more gas to join the party, which expanded the gravitational power, which engaged considerably more neighbors, and so forth, like brilliant music at a local party, going much the same way in alarm tune to help more rares. All through an enormous number of years, the rich gas got more substantial and the mournful gas got less fortunate through essential gravity. Little thickness contrasts created, constructing the first gigantic participant of matter and exhausting out their environments. Somewhere, some part of fair-minded hydrogen got fortunate, keeping layers resulting to overwhelming layers on itself. The most profound center came to a critical temperature and thickness, driving tangled structure, reaching off a nuclear mix and changing over the harsh substance into helium. That savage cycle too conveyed a touch of energy. And in a burst, the chief star was brought into the world, curiously, starting from the hidden dozen minutes of the immense blast. Nuclear reactions happened in our universe, new wellsprings of light dotting the universe, flooding the once void voids with radiation. These new wellsprings of radiation re-energized the fair hydrogen that filled the universe during the supposed epoch of reionization. Through gravity, greater and more eccentric plans emerged, constructing a tremendous, colossal weaving of universes. In the meantime, everything continued to fly isolated. The stargazer Edwin Hubble sorted out during the 192s that the universe is broadening. And in the late 1990s, his namesake, the Hubble Space Telescope, tracked down confirmation that the augmentation is speeding up. Consider the universe a sum portion of raisin bread. It starts as a blend of bloom water, yeast, and raisins. When you merge these decorations, the yeast begins breathing and the part begins to rise. The raisins inside it substitute for systems, broadening further isolated from one another as the part fosters. The Hubble telescope saw that the piece is rising of all time quicker. The raisins are flying isolated at a rate that goes against their gravitational interest. This speed increase emits an impression of being driven by the horrible energy of room itself, guessed faint energy, which is would in general by the Greek letter lambda, plug values for lambda, cold weak matter, average matter, and radiation into the territories of Albert Einstein's in general hypothesis of relativity, and you get a model of how the universe encourages this lambda, cold weak matter. One procedure for testing this image is by looking at particularly distant immense structures. Unclear from thinking back to the basic not many 100 million years after the colossal a case that started it all, the universe was more straightforward than its headway, more straightforward to analyze against assumptions. In any case, as examiners utilized James Webb to dive into the underlying segments of the universe, they found something that shouldn't exist. These astonishing exposures then, at that point, put the academic neighborhood in issue in that they should look at the very basics of what they are familiar cosmology, explicitly practically. Following the Webb telescope completely turned on in July 2022, James W.G.'s astonishing infrared mindfulness revealed the weak sparkles of universes, clearly from the far-off universe, that had formed basically various a broad time frame after the gigantic impact. Space experts had expected such accomplishment results to emerge much more comfortable. In any case, more than speculated, there was an impact of information. Those early outcomes happened so rapidly, considering the way that analysts utilized a clever, critical course to check colossal distances. Cosmologists, for the most part, stuck down unlimited course through logical LY evaluating redshift, a loosening up of a universe's light toward the red end of the electromagnetic reach as a result of the universe's improvement. But this requires the appearance of social event and investigating and endless structures come to a time-consuming and unpretentious process known as spectroscopy. The James Webb Space Telescope's fire hose of revelation was genuinely fueled by cruder, quicker photometry-based techniques that essentially utilize clear combinations in a system's brilliance to actually take a look at their red change. As such, while the photometric outcomes came thick and fast the previous summer, the spectroscopic results have started streaming but by an exceptionally restricted edge out as of now, at any rate, with spectra-based distances close by from something like 12 candidate researchers are finding that most appraisals are matching the early photometric results. The most recent, appropriated in Nature Astronomy, certifies prior distance measures for extra frameworks recognized by the Farad Significant Extragalactic Outline, as shown by Emma Curtis Poole of the School of Hure in Britain, who drove the spectroscopic results. We have been accepting that this will have the decision to do it inside the essential start somewhat couple of months of this telescope. Was just fantastic. Of the four, the most distant is united with the fairly stumbling named Gonzi. It has a redshift worth of 13.2, meaning we are seeing the structure as it appeared only 320 million years sometime later the huge explosion. That high redshift makes Jade 0 the most far off at this point known in the universe, a record that the James Webb Space Telescope appears set to break once more. Yet one inescapably that highlights space experts are so the nuclear focuses together in a stimulated. We at this point know for unequivocal we are attempting a period of the universe no human has at any direct looked at earlier toward its dazzling. Says Peter Van Destruction of Yale School, this cosmic structure, he curiously notes, is just barely more settled from our point of view than the overall time sharks have existed on Earth, approximately 300 million years. As such, you go from nothing to these unquestionable universes in the glint of an eye. But not all high redshift competitor in admirable structures have been so fortunate, which highlights cosmologists' early consideration. In July, another blueprint called the Unending Movement Early Delivery Science Review drove by Felstein, regardless of what a likely universe at a redshift of 16.4, only 240 million years after the huge blast. Coming to fruition, spectroscopy has shown that settlement was off track, as uncovered in late March in research led by Pablo Arabel, and cosmologist at the National Science Establishment NOR Lab. The world is everything thought of a dusty joke, organized at a redshift of 4.9, still amazing but not at all shape or form record-breaking, 1.2 billion years after the Goliath impact. Raised levels of star headway are made a point to have tangled early photometric assessment, as Colm Donan of the School of Edinburgh in Scotland, a co-producer on the work, figures, we can be without any problem misled by contamination. A high redshift universe can be reproduced by a lower redshift boundless system with various highlights. The expected gain news is that this specific universe gives off an impression of being an remarkable case. Donna says, a comparable study had the decision to affirm that two other candidate universes didn't have a similar issue. One of these is Mother Structure, which is seen at a redshift of 11.4, around 400 million years after the tremendous blast. Now that such universes are being attested, their rational thoughts can be significantly more completely investigated. These universes are minimal, a colossal number of times more unobtrusive than the smooth way, yet some show up outstandingly amazing and huge and have high star for rates, like that of our reality, which for outlines about one new star dependably. While the universes make an effort not to yet present issues for driving models of cosmology, they suggest huge upgrades began already and continued incredibly quickly in the universe, which scientists had in advance anticipated. Started making universes prepared age of 1 billion years after the gigantic blast. We're seeing a move of Goliath enormous frameworks quicker than we typically thought ahead of time, says Fabio Puy of the Harvard-Smithsonian Place for Space Science. The seasons of a piece of these early structures are overviewed at simply a huge number of years. This could have ideas for Goliath plans of faint matter known as crowns that scratched early universes and for faint matter particles themselves, like Sandra Ticella of the School of Cambridge explains. One of the monstrous open demands is weak matter. The start of enormous frameworks is a touchy test for different dark matter models, some shaky and maybe model busting. Early universe up and coming universes, in reality, remain first among them might be a class of endless structures perceived by abhorrent Labby of the Swindon School of Headway in Australia and his accomplices. The group tracked down universes with billions of sun-based masses, essentially vague in weight to the smooth way from just an anticipated 750 million years after the colossal blast. These universes are 10 to on various events more noticeable than universes actually found in this period and are fit into structures on different events more unaccepting than the smooth way. They're little yet they're huge, says Labby, who says Joe is continuing to find comparable systems on a very basic level anywhere. The universes have, so to speak, can be concentrated by photometry with spectroscopic assessment.